Alright, so in that last video we had just left off saying that cosine x could either equal -1/2 or -1. Now we're going to see at what angles that would be true. So if I think about my unit circle, cosine would be negative, since it's my x coordinate, in the second and third quadrant. And if I use the first quadrant to kind of help me think about where cosine is +1/2, that would be up here at pi/3, and so I want that corresponding angle in quadrant 2 and quadrant 3, and that would give me 2pi/3 and 4pi/3. Now if we look closely at our interval, this says all solutions, so we don't just want a full circle 2pi. I also would like, if I continued, all solutions that are coterminal with those two angles. So the way I can represent that is as an equation, and write this as 2pi/3 plus 2pi_k, where k is any integer, and 4pi/3 plus 2pi_k, where k is any integer. So this would represent all the solutions that are coterminal with 2pi/3 and 4pi/3. For -1, if I think about where cosine or x is -1, that would be back 1 right here at an angle of pi. So I get one solution there, pi, but I want all solutions that are in that same, have that same cosine value, so I'm going to say plus 2pi_k for that one as well. So I have three equations here to represent all the values of x that would make this equation true. Okay, let's talk about our box method. I'm going to do the same problem now for those of you that prefer factoring instead of the quadratic formula. So let's take a look. We should get the same three equations that we got for this first strategy. So I'm going to set up a box method for factoring. You can factor however you'd like. I'm going to put 2u squared in here, 1 in here, and 3u off to the side. And remember, whenever I have a coefficient right here on my squared term, I need to multiply that times this constant. 2 times 1 is 2, so I'm looking for factors of 2 that would give me a sum of 3. So 1 times 2, or -1 times -2 are my only options for factor pairs of 2. And 1 and 2, +1 and +2u, would add up to 3u. Okay, so pulling out common factors, I'd have 2u and u. 2u times 1 is 2u. U times 1 is 1u. So I end up with 2u plus 1 times u plus 1 is equal to 0. Replacing those u's with cosines, that means I have 2 cosine x plus 1 and cosine x plus 1 equals 0. And now I'm ready, because of the zero product property, again, to break these into two separate equations set equal to 0. And solve like normal. So subtract over my 1 on this side. 2 cosine x equals -1. Divide by 2. I end up with cosine x equals -1/2 for that equation. And on this side, just subtracting 1, cosine x equals -1. And I end up with, perfect, the same values I had using the quadratic formula. So this strategy gives me my same angles that we discussed earlier, 2pi/3, 4pi/3, and pi, but I want to write them all as equations because my interval is not a specific finite set. It's going for all solutions that are coterminal with these angles. Okay?